Thanks for joining us again on Chem with Chem, where we find the solutions of our chemistry problems. We also look at common labs that are done at CXC. So if you like what you see or hear here, be sure to sign up for a tutorial session with Chem with Chem. All right, so in this session, we are going to zone in on question 2 from the January 2024 sitting. That's the resit, right? So let's go right into it. W, X, Y, and Z are 4 elements found in the periodic table. Their positions in the periodic table in relation to the element sodium and chlorine are shown in figure 3. Now, before you do anything, don't try to figure out what W is. Don't try to figure out what X is. Don't try to figure out what Y is. Do not try to decode what Z is. They did not ask you to do that. If you know how to do that, or you know what W would be representing, even though they're not asking about it, then leave it alone. You're not to say W is anything. They're checking to see if you really understand placement, how elements are placed in the periodic table. So they're asking, state how the elements in the periodic table are arranged. Now we have 3 ways to arrange them. They're asking us for 1. So the best one that would give them here would be this one that we will allow to be filled in just now. That's it. So elements are arranged based on increasing atomic number. So that is what we really want to get from here. We're also going to move on to part B, using the elements W, X, Y, and Z from figure 3 above. State the pair of elements found in the same period. Now, I don't want to say there's a little trick on the pair. Pairs come in 2. So apparently, W is next to sodium. We could call it a pair. We could call those 2 a pair. But even though Cl is far from W, we could call W and Cl a pair as well. It's just that they're far apart from each other, but they're all in the same period. So any 2, so we could say here, any 2, so we could say any pair or any of the 2, that's how we'll treat it. Any 2 of Na, W, Cl, Z, or we could use X and Y, right? So those would be the pairs. Next part, identify the elements in group 2. So the elements in group 2, this is group 2 right here. Not sure if we can line it up. We should be able to draw something there. So this is group 2, Roman numeral 2. So we're coming back from that. They want us to look at the elements in group 2, which would be W and X. We don't need to decode anything. So we're just gonna write that in. All right, state which element is group 2 is more reactive. Now we know reactivity increases down the group for metals. Part 4. This is part 4 of B. Write a balanced chemical equation including the state symbol for the reaction between element X and dilute acid. We might lose some subscripts here. All right, so let's put in underscore to tell us where we'll have subscripts. So the aqueous there is underscore. That's our arrow. So this is that's underscore as well. Okay, we're now at part C, part one of C. Sodium and chlorine are pure substances. However, they're found combined in sodium chloride, which dissolves in water to form a mixture. State the difference between a mixture and a pure substance. All right, let's just get right into this. So a mixture consists of two or more substances, which can be elements and or compounds, which are physically combined together in variable proportions. It's not a fixed proportion or fixed ratio. A pure substance is composed of a single type of material only. All right, and then we want two other examples of a pure substance. So we'll go for the example. So we cannot use water, we cannot use sodium by itself, we cannot use sodium chloride. We'll do something else. Let us use carbon dioxide is a compound, which is pure. So carbon dioxide, and then we have oxygen. It's an element that's pure. It's an element, so it's pure. We could also put gold. All right, and we're not really overdoing it. So we have a compound, then we have an element, then we have an element. Let's look at another compound. So we don't want to use water again, we just use it. We could use ammonia. It's a compound, it's pure. Pure substances are elements or compounds. Name the type of mixture formed when sodium chloride is dissolved in water. The type of mixture there, let's see. There are two ways we could approach this. Either would be correct. We could say it's a homogeneous mixture, or we could call it a solution. All right, solution is a homogeneous mixture. Those would work. Then we're now at part 4 that asks us to identify a separation technique that can be used to remove the sodium chloride from the water. All right, so see if we can manipulate this nicely. Okay, we can work with this. So we would need to clear this out. So the technique that would use to remove sodium chloride from the water is evaporation. One of my favorite separating techniques. And down here now, we're near to the end. Another salt of chlorine, silver chloride, does not dissolve in water. Name the type of mixture formed when a small quantity of silver chloride is added to a beaker of water. So straight up, earlier on, we had a salt that was soluble in water, and we named it. We said, no, well, not named. We stated the type of mixture that would be formed. That would be a solution or a homogeneous mixture. We want to get a little more specific here because we have a type of heterogeneous mixture that will be formed, and we want to get it right. We want the best answers. All right, so here for sure, this is going to become a suspension. Not a suspension that people get at school. None of you should be getting suspensions anyway. But we're talking about the solute particle only dissolving partially or not at all. So it would form clumps or it would settle out at the bottom of the container when the whole setup is left to stand. So suspension is what we have right there. And then part 2 of D, they ask us to suggest a separation technique that can be used to remove the silver chloride from the beaker of water. Now, once it's a suspension, the solute particles are large, too large to be trapped by the pore in filter paper. So we can use filtration. filtration. And that would give us full marks. Again, if you find value here, I'm encouraging you to share the value that you found, because sharing is caring. I'm also asking you to, you know, consider subscribing so you don't miss out anytime content is added. And I would also invite you, encourage you to book a tutorial session with me, with Kim, and let us start our chemistry journey together. You deserve to get that one. Put in the work and let's make it happen. All right. Thank you again for joining Kim with Kim. Properly.